All right, solving a system of equations in 3 variables. This is just going to blow your mind, and these first couple minutes I'm going to talk, just absorb and feel the wonder. Okay? If you have 3 variables, that means you have a plane. Okay, well, if you have 3 variables in an equation, that means you have a plane. It's a 3-dimensional figure. So if you have a plane is like this this one right here, this orange one is like a plane, and all 3 cross, you wind up hitting them, they hit at a point, and that's most of the time, that's all the time that we're going to be working with it. It will end up with a point, an X, a Y, and a Z that are the same. But sometimes you can have it, all 3 intersect at a whole line, which is pretty fantastic. And then there's the ones where they don't all intersect. Either they're, all parallel to each other, or one cuts through and the other are parallel, or they all just kind of hit each other. So these are all the different things that can happen, and this is actually what we're going to be doing, is mostly this one right here. I know you just got mad at me, but that's okay. I don't get this at all. Follow it, and it's really not too bad, the whole process of doing this. What you need to do is kind of follow these steps that I'm giving you, as you're looking at. Follow these steps, step by step, as we go through them. And hopefully, as I go through a problem, you won't be too confused as to these pretty pictures that were up here. Okay? All right, so we're going to be solving system of equations with x, y, and z with 3 variables. Now, sometimes it's not just x, y, and z. Sometimes it's a, b, and c. Sometimes it's p, q, and r. They use different letters all the time, but just know when you write the answer, it's x, y, and z. And truthfully, you don't have to write it as a point. You can just say x equals y equals z equals, but sometimes say it's multiple choice, and I give you a choice. It's always going to be always alphabetical. Alpha. Okay, so if it's ABC, it goes A, then B, then C. Okay, I don't have to explain that again. So here we go. So to do this, what we do is we group these together. You want to take a good look at the problem and say, which variable do I want to be rid of? In this particular one, it doesn't really matter. I'm just going to get rid of x because it's out front. But it doesn't really matter which one you get rid of. You either have to get rid of x, get rid of y, get rid of z. Okay? So I want to pick 2 of them. So I'm going to pick the first 2 and get rid of x. Again, you could have picked y's. It doesn't matter. I'm just choosing x. So I'm just going to rewrite this over here. That's a z. I swear to God, that's a z. I can't erase it now because of this mess. Equals negative 10. And then 2x plus y plus 3z equals 0. And I'm going to eliminate x. Now this is elimination. This is just like those linear equations that we did before. We use elimination, and this is where it's useful to us. So we hug the whole thing, crisscross. Now, if you can see it, I'm just going to talk about it for a second. If you can see the fact that if I simply multiply this one by 2, it's going to make this 4x. And I want to eliminate that, so I'm going to make it negative 2. So when I multiplies it through, I'm going to do negative 2 times positive 2, and it's going to be a negative 4x. So when I add them together, the x's are going to go away. So I don't have to necessarily crisscross, though that does work. So it's 4x. Forgot to change my color, plus 3y plus z equals negative 10, and then I'm going to distribute this negative 2 through the whole thing. Okay, so it's negative 4x, and that's our goal. Get those opposite. Minus 2y minus 6z equals 0. I put my line through my z because it's hard to tell if it's a 0 or 2 sometimes. So these go away, and that was our goal. So I'm left with negative 5y minus 5z equals negative 10. So we just simply add those up, and we get an equation with 2 variables. All right, big whoop. So then you come over here, and you do that again with 2 other equations. So I'm going to pick these two this time. So the first time I picked these two, the second time I'm picking the bottom two. I could have picked the first and the last. It doesn't matter as long as it's two other ones. It doesn't matter which two you pick. So the problem with grading these two problems is everyone does it different ways, and it makes it kind of difficult to see the problems. So, you know, just get it right the first time. I'm sorry. I'm just kidding. Okay, so looking at this, if I multiply this bottom one by 2, again, I just got rid of x's over here, so I have to get rid of x's over here also. So if I multiply this whole thing by 2, I'm going to make this one a negative 2, which is what I would really like. So the top one is 2x plus y plus 3z equals 0, and the bottom one is now negative 2x plus 4y minus 10z equals, what, 34? Okay, so I just distributed that 2 through the whole thing. Made a mess of my paper. Those cross out. I'm left with 5y minus 7z equals 34. Now what did that do? Well, that made two equations with just y's and z's in them. So what I'm going to do is just now, I just took these, separated them out. Now I'm going to bring them back together. So the process isn't really all that hard. It just takes up a lot of room. So now I'm going to bring them back together and use elimination. So negative 5y minus 5z equals negative 10, and positive 5y minus 7z equals 34. So I'm bringing those together. What's nice, if I just add these up, this one turns out well, these y's are just going to cancel right out, and I'm left with negative 12z equals 24. Divide by negative 12, and z is negative 2. So I got what z is. Go me. Woohoo! Now I need an x, and I need a y. So I'm going to go back. I'm going to take either one of these two here, either this one or this one. I'm going to plug my z in, and I'm going to get an x out. I'm going to change my color here. So negative 5y minus 5z, which now I know is negative 2, equals negative 10. Plug that back in. Negative 5y plus 10 equals negative 10. Right? Yep, so subtract 10. Negative 5y equals negative 20. Divide. And I get y is equal to positive 4. Oop. Y is equal to 4. Okay, good. We got y done. Now we have to go back to x. So now we have to go back to the one of the ones with the 3. So I got to take this guy, come up here, and see any one of these 3 I can use. So I'll just use the first one. Oh, it doesn't really matter. I'm going to pick one that I can see from here. So my job is so much fun. So I can see that I'm going to choose this one, and hopefully I wrote it right. So 2x, I don't know what x is, plus y is 4, plus 3z, z is negative 2, equals 0. I like the 0. Easier work for me. So 2x, and that's 4 and a negative 6, so minus 2 equals 0. Add 2. 2x equals 2, divide by 2, and x is 1. Bam! I got an x, I got a y, I got a z. I'm done. Woohoo! All right, so we're gonna you can try this one if you want on your own. It's one of those things where you do have to kind of be with someone that understands what you're doing, because you can eliminate any one of the variables. So if you don't mind, eliminate x's here, just so that it's easier to follow when you see my work completed. Okay? So try this one on your own, and then bam, magic's going to happen, and you're just going to see my answer. Okay, just I have an answer here for you. Oh, the fun. I got rid of the x's, and if you could see the two equations that I took the first two and then the first and the third. It doesn't have to be the first and the second, second and the third. It doesn't make any difference, the order. So I combine those, got rid of my x's, put them back together, and my answer, x is 2, y is -1, and z is 1. So pause it, take a look at it, but have a good day.